get started today. We are moving into PHP today, and after that, JavaScript. The pair, PHP and JavaScript, are what we use to create websites. And PHP is the most commonly used server-side scripting language. JavaScript is the most commonly used client-side scripting language, which is why we are covering those two. They're both platform independent, meaning that they will work across Windows, Linux, Macintosh, which is an added bonus. So we're going to spend the next 2 weeks on PHP, and then the final 2 weeks of the course on JavaScript. Before we do that, I had a question show up on Piazza that I just wanted to quickly point out something about how graphics are handled on computers. So the question that I received was why I had the equation bottom equals top plus height, because that doesn't seem to make sense. If you think about the traditional coordinate system and you have a rectangle on that coordinate system, then this would be the top and this would be the bottom. And according to what you were taught in geometry class, bottom is going to be equal to top minus height. Yet my claim in the homework assignment, which was correct, is that it should be top plus height. And the reason for that is because of the way computer displays represent the y-axis. So on computers, your actual Cartesian product or axes look like that. They start at the top of the screen and they go down. The y-axis goes down rather than up. And therefore, this is 0, this might be 10, this might be 30. And in fact, bottom is equal to top plus height on a computer display. The way it's like that is because in the early days of computers, the way scanning was done, or the way output was sent to a cathode ray terminal, was that they sent it top to bottom, left to right. So the topmost thing that always got output was up there at the upper left-hand corner, and therefore that's how they set the display coordinates, the axes. So on a computer, the y-axis starts at the top of the window, not at the bottom of the window, and therefore everything that you learned about Cartesian geometry is reversed. Okay, so it wasn't a typo on the homework. Bottom really is equal to top plus height. All your calculations on the x-axis are as you would expect, but on the y-axis, they're inverted. Okay, and that's always true. It's not just my assignment that did that. That's all graphical user interface libraries are like that because that's how displays are still set up. Questions about that? Okay, so PHP was designed to solve a problem. And that problem was that in the early days of the web, pages were static. So you could have a static web page, but if you wanted to have something like an updated stock quote or an updated score, or you wanted to be able to enter some information such as a credit card and send it back, these things weren't possible. So web pages were effectively read-only, and the user could not interact with them other than by clicking links, hyperlinks, and going to other pages. So this was not something that was particularly desirable, and I forget the person who, let's give the person his due. PHP creator is Rasmus Lerdorf. So Rasmus decided that he would like to be able to have interactive web pages. So he created a language called PHP, which stands for, or used to stand for, personal homepage. I think it means something different these days, but the original meaning for PHP was it was an abbreviation for personal homepage. And it was meant to allow someone to dynamically generate content for web pages. Now, the primary purpose was on the back end. So actually, PHP isn't meant to give you yet interactivity on the front end, on the client side. Instead, it's meant to be able to customize web pages that are served to your computer. So for example, instead of just having a web page appear on your computer, maybe it would be personalized with your name. So each of us would see a different web page coming up, perhaps with our name at the beginning. And the way that he accomplished this was that PHP can be used as a so-called embedded script within an HTML page. So for example, let me do that. Whoops, I'm on the wrong system. So I'm going to create a file called foo.php, and I'm going to create some HTML content. So for those of you who have not seen HTML before, HTML is a markup language, and you use tags to distinguish content. So in this case, the tag h1 indicates that this is a primary header, and it will be formatted as such. And then you terminate every tag with the corresponding tag, but with a slash before it. So if I just do this and actually save it, you'll see that it's actually a file called foo.php. And if in my web browser I type in web.eecs.utk bvz temp foo.php, nothing happens. Why does nothing happen? Let's see. First of all, is it readable? No. So it's not world readable. So let's make it world readable. And then we'll do it again. And now it comes up with this as a headline. So if something doesn't appear immediately, one of the first things you should check is whether you made it world readable. So that's fine, but this is static. This is just HTML, but it's showing you already that I created that page from a .php. The real power comes from being able to embed PHP code snippets. So a PHP code snippet is inserted with the less than sign question mark PHP. And then you can insert stuff. So here's a very simple PHP program that's going to count from 1 to 10, or from 0 to 10 rather. And I am going to print, and you're going to see something. We're going to play with this. And I terminate it with a question mark greater than sign. So that's going to print out some stuff, as we will see. So I'm going to reload it, and it comes up with 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, I might not want them all smashed together on one line. So you might think to cleverly add a backslash new line character. And that has absolutely no effect other than to put spaces between them. Okay? Could actually run it from the command line and it would do what I want it. It would actually create that particular web page or output, which would be interpreted by the browser this way. So it translated the new line characters to spaces. So one issue when you're dealing with web output is that browsers don't interpret new lines the way the console does for your laptop. Instead, you have to use HTML markup commands if you want to get your output to be nicely formatted. So in this case, if I wanted new lines, a crude way to do that is to put a tag at the end of my each one, which stands for line break. That's an HTML tag saying break the line. And if I now output that, then it works. And if we look at what actually was output by the PHP, it actually looks like that, which is pretty ugly on the console, but showed up rather nicely on the page because the BR tag says to break the line. And in this case, you don't have a start BR tag. You could. I could have actually, if I was technically doing things, I could do that. And then there's a matching starting tag. But when you don't have any content and it's just meant to be a formatting command like that, by just putting the one tag with the end, HTML understands it's both the beginning and the end of the tag. Okay, I could do other things. I'm not going to, this isn't an HTML class, but I could also have made this be an ordered list. So I'm putting the ordered list part before and after because that's part of the static content. And then instead of printing a new line character, I'm actually going to do a line item tag, dot it with I. And if I run in PHP, you see I get what looks like a bunch of LI tags, but if I put it up here and I reload, then it's been nicely formatted as a list, an ordered list. So PHP, what it allows you to do is essentially create dynamic web pages. And you can embed both static and dynamic content on the web page. So the headline, this is a headline, that's static content, as is the ordered list tags, but the dynamic content in this case is the contents of the list, which I have dynamically generated using PHP. So these small snippets of PHP code inside the file are called PHP code islands. You'll often hear them referred to as code islands. So they're embedded pieces of PHP code. And between code islands, the values retain their meaning. So if I now have another one here, and I say h1, and now I'm going to create another PHP code island, and I print I equals $I. This is going to use interpolation. Now I put h1. What you're going to see is that the value of $I was remembered between code islands. It didn't go out of scope when the first code island went out of scope. So you can see I equals 10 down here at the bottom, or if I just reload up here, I get I equals 10. So variables defined in one code island remain defined throughout that page, which is also handy. So that's the essential innovation that was introduced by PHP, this ability to dynamically create custom content for HTML pages. And you can see up here that I've entered it just like I would a HTML file, except instead of it being named foo.html, it's named foo.php. And what happens when I type in that URL, the browser, or actually somewhere, it's being sent to the back end. The back end sees that it's a .php file, and it runs a PHP interpreter. And that PHP interpreter creates output. In this case, that output looks like this right here. That output is then sent back to the client. The client's browser interprets that as HTML and displays it. Now, it doesn't have to be HTML. That's the default if I don't say what the doc type is. But in fact, I can send back other types of files. I could send back a Flash file. I could send back a JPEG. It doesn't have to be an HTML image. If you look at the notes, go to the notes for today. Whoops, I want W3 schools. You'll see in their very first example that they actually put a doc type tag at the top of the file. If that doc type tag is absent, a browser will by default assume the text file should be interpreted as HTML. But you can put different doc types up there, and that will cause your browser to interpret the output according to whatever doc type you specify. So if I specified that the doc type was a Flash file, then it would interpret it as a Adobe Flash file. If I said JPEG, it would interpret it as a JPEG file. So a PHP script doesn't have to output HTML. It can output any type of file as long as it starts it with the appropriate doc type tag, and then it will be interpreted. In this course, we will assume that it is an HTML file. So I'm going to actually write down this little sequence. So what happens is we have over here the browser. And step one is you type in a URL that's going to presumably terminate with a .php. That URL will determine a server. And the server will, so that's step one. Step two is it executes the .php file using a PHP interpreter. So that's step two. That's being performed at the server. So the server. Step three is it sends back the output. So PHP output goes back. And four, the browser interprets it according to its doc type. And as I said, anything that appears outside a PHP code island is simply output verbatim to the output. So anything outside a code island is static, is simply directly copied to the output. Okay, so very nice, very simple. PHP is syntactically very similar to C++, but it's a much more modern language than Perl, and so it corrects some of the egregious syntactic anomalies of Perl. And PHP also has embedded in it many features that allow you to interact with both web forms and with databases, two critical things if you want to have a good server-side language. So there's reasons why PHP has become such a popular server-side language. There are other languages that are available. For example, Perl itself can be used as a server-side language. But to do that, you need to load a CGI module from CPAN in order to make it function as a server-side language, whereas in PHP, all these features are simply embedded in PHP. It was designed as a server-side language. You could use something called Java Server Pages, JSP, which is certainly a heavier weight way of doing it. Java Server Pages use the Java language, and you don't have the lightweightness of PHP nor the flexibility you get with an interpreter. You could use Microsoft ASP, which is Microsoft's proprietary server-side language, and as you might expect, it doesn't work particularly well across platforms. Works quite well with Windows platforms, but not so well with Macintosh and Linux platforms. So it hasn't been as widely adopted because PHP is more portable. So those are the big alternatives. I think Ruby is also now often used as a back-end scripting language. In fact, Twitter was originally completely written in Ruby until they discovered as they grew that Ruby at the time did not scale up, and they, if I'm not mistaken, had to rewrite it in another language. These days, though, as far as I understand, Ruby is industrial strength and could be used as a back-end language. However, if you look at rankings of top 10 languages, PHP is still generally top 5. This year, it seemed like Ruby slid into the number 10 position in popularity. So PHP is still the number 1 language for server-side scripting. ASP does not make the top 10 list. So today, we're basically just focused on the syntactic features of PHP, and I'm going to go through those rather rapidly. I'm also going to show you, importantly, how you get a PHP file to execute on your computer. And then the remaining 3 days of the PHP are going to be talking about how it interacts with web forms, so how it interacts with the browser, how it interacts with the backend database, and you're also going to be introduced to another type of data storage format called XML. But today, we're just worried about the syntax of PHP. So, let's say you want to get your own PHP file to work. How do we make that happen? So you'll need to log into your CS account. You saw me do that earlier, but I'm going to log out right now. So the first thing you're going to have to do to make your PHP script work is you'll probably want to log into one of the Hydra or Cetus machines. And then you have a directory called webhome, okay, which all of you should have if you have a CS account. Webhome is your public repository for where you can put things that you want displayed on the internet. When I type web, if I just type web.eecs.utk.edu/tilde-bvz, it goes and looks for, it goes to my web home directory, and it looks at the index.html file there. So if you don't specify what to look for in the directory, it looks for a file called index.html. And that's why if I just do that, you see my home web page here at UT. You saw that I had to make it world readable. So if you look at the permissions for index.html, you see that I gave read and write permission to myself and only read permission to the outside world. This is incredibly important that you don't give write permission to the outside world. Okay? This is basically, if you give write permission to the outside world, you're letting hackers essentially into your account, and by extension, you're pretty much allowing hackers into the university system. Just by being careless and not setting your permissions appropriately. Now shouldn't be that bad if it's just a HTML file, but someone could certainly get in there and do all kinds of malicious stuff to it. Okay, so I try to be careful. As you can see here, I give myself read-write permission, but I give everyone else just read permission. Now, let's say that you want to create an executable PHP file. First of all, I suggest you don't put everything in your top-level web home directory. As you can see here, I have a directory named temp because that's where I put my temp files. And if you look at the execute permissions for temp, you will see that it's read, write, and execute. For me, you have to give directories read and execute permission. If you just give a directory read permission, it won't do any good. So for example, if I change, that's horrible, I hate that. If I say change mode 07, I'm only going to give read permission to my temp directory. Now, if I go back here and try to say temp foo.php, shouldn't have worked. Probably cached. I don't really want to clear my cache. Okay, well, try another file. That's a good one. Let's try find inventory.php. It's surprising that why? Generally you need execute permission to get into a directory. At any rate, you should give the directory permissions as execute. I'm not exactly sure why it is allowing me to get into that directory without execute permissions, but it is. So in general, the directory should have read and write permission. And then you put whatever you want your file's name to be. So now by giving, you'll notice web home is nowhere in this URL. That's because UTK automatically goes to my web home directory when I type in ~bvz. So in fact, the first directory is the top level directory temp, and then the name of my PHP file. Okay, so that's how you can create your own executable PHP files. Now, if you have a syntax error, let's see what happens. So I am going to leave out the less than sign. So that should create a syntax error. And as you can see, I now get a blank page. So when you get a blank page, there's different things you need to look at. First of all, make sure that the file is readable by the outside world. But if it is, the next thing to do is to determine if there is a syntax error. And the way you can do that is there is a command line interpreter called PHP. And if you give it the name of the file, it will execute. And you can see it says PHP parse error, unexpected 10 in foo.php at line 4. And indeed, that's the problem. So I typically run things through the command line interpreter before I try to run it on the web because I'm not going to get any useful information on the web. The reason for that is to foil hackers. So when our lab staff installed PHP, there's an option that allows the lab staff to specify whether syntax errors will be echoed to the display or not. Does anyone know why it's not a good idea to echo error messages to the screen?
More idea of the structure of your...
Because hackers can get a much better idea of the structure of your website if you start echoing error messages to the screen. It's just a roadmap to hackers as to how to break into your system. Okay, saying, well, not this way, but if you correct this error, maybe there will be entree. So generally, when you install something like PHP, you specify that if there are syntax error messages, they will not be displayed. You'll just get a blank page like that. So two things to do when you get a blank. So blank page when running a PHP script. One, check to make sure that it is world readable. Two, run it through the command line interpreter. To check for syntax errors. Okay, there is a third possibility. Okay, third possibility is it works for the command line interpreter, but not for when it's run on the web page. Three, it may be your script may have a disabled feature. May have a web disabled feature. Okay, often associated, for example, file ops. So there's a whole set of file and directory operations that will work fine if you run the script at the command line, but which will fail if you try to run that script on a web page. For example, moving a file between directories or deleting a file will generally work just fine if you run it through the command line interpreter, but if you try to run that same script in your browser, it will no longer work. Okay, and that again is to essentially stop hackers from being able to do nasty things. So it's fine if you're running it yourself, you're a trusted user, but our lab staff again doesn't have a lot of faith in us to write code that is safe. It's too easy for us to write code that's going to give hackers access to the system. So they simply make a lot of the features disabled, especially the file features. Okay? So questions this far? Okay. So I am actually going to run through the PHP features rather rapidly because, as I said, PHP was styled after C++ and C, so it's pretty easy to program in it if you've seen C or C++ before. By the way, if you say webhome foo.php, it doesn't work because it's actually looking for ~bvz/webhome/webhome. So that doesn't work. Okay. Okay, so a number of things. Again, remember that code islands start with a less than sign question mark PHP, no spaces, and they end with a question mark greater than. You also are allowed to use, if I want to say, for example, H1 hi, and I don't want to have a PHP embedded thing because I just want to print out a variable name, I can do this, question mark equals $name. And that's a very small embedded PHP island. It can't execute generic PHP code, but you can put the name of a PHP variable. So this is a PHP variable, and it will interpolate in the name of the PHP or the value of that PHP variable. So that's a little simpler. That's what you do when you have an inline small PHP code island that just needs the contents of a PHP variable name. Okay, so PHP has most of the characteristics that we've come to associate with scripting languages. It's interpreted, it uses dynamic typing, variables do not have to be declared, lists and hash tables are built-in data types, and it provides system-independent ways to deal with files and directories. So variables do have to start with $, which I find to be rather annoying, but they don't have to be declared. So here's just a couple very simple ones. And I wouldn't generally put stuff in, so you can interpolate. So here, actually, this is confusing. This is saying $A equals 20. Then these weren't meant to suggest that you could assign 20 to $A. What it actually was meant to suggest was that if you use double quotes in a PHP variable inside of it, it will be interpolated. So if I say print $A, it doesn't literally print $A, it will print the contents of $A. So if $A is 20, it will actually print 20. However, if I use single quotes, then it actually will print $A because it doesn't interpolate into single quotes. Sometimes you need to be able to tell PHP where the variable name ends. So let's say I wanted to print out pounds and I didn't want any thing. If I did it this way, it would get something about $ALBS being undefined. When what I really want to do is print $a pounds. So the way I do that, I don't actually put the curly braces around the pounds. I put the curly braces around the variable name. And that tells PHP where the name of the variable ends. That's only necessary if you don't want a blank space between the end of the contents of the variable name and whatever follows it. Okay, concatenation operator is dot. Unlike Perl, the relational operators apply to both strings and to numbers, so they work equally well with either. There are useful string functions that I'll just let you read about. There's no real reason for me to go over them, but there is one handy one that you should be aware of, and that's called trim. It's a better version of chomp. In Perl, what did chomp do? Remove the new line character. But oftentimes you want to remove more than just the new line character. You actually want to remove any trailing white space, which might include blank spaces as well as the new line character. You also often want to remove any leading white space characters, and that's what the trim function does. If you leave off the char list, then it defaults to removing leading and trailing white space. If you include the char list, then it will trim any leading or trailing characters that are on that char list. And there's also an ltrim and an rtrim command, which do what you would expect. Ltrim only removes leading characters on the left-hand side of the string, and rtrim only removes trailing characters on the right side of the string. Okay, and unlike chomp, trim returns a copy. It doesn't do in-place editing. So this class of commands returns a copy. It does not do in-place editing. Okay. So then the types for PHP are the ones you expect: integers, floats, booleans, and in PHP, the Boolean constants are true and false. And it doesn't matter whether you use uppercase or lowercase. In fact, PHP's keywords are all case insensitive. You could actually write FOR, or you could write lowercase FOR, or you could be just, doesn't matter. The keywords are case insensitive. So the Boolean values are true and false. There is also a null that is equivalent to undef in Perl. Means that you're assigning no value to the variable. PHP does have a form of pointers, which also, in that case, null would mean a null pointer, but you can also assign null to any variable to, in effect, make it undefined. PHP does have a reasonable class system, which we will not be talking about, but it looks a lot like C++'s class system for syntax. Then there are built-in arrays. Unlike Perl, the array syntax is pretty much the same. So if you want to create a linear array, so it calls it array, it's essentially a list, although it's implemented as an array. You can say $A equals array 3, 5, 8, and that will create a list consisting of the numbers 3, 5, and 8. Or you can simply go ahead and create it by assigning items directly to A, like that. Or you can append, if you say A equals 8 with no, notice there's nothing right there, that will append. So this appends 8 to the end of the array. So you can simply write this expression and it will create an array for you. Or if it was originally undefined, you could just write $A equals 3, and that will create a one-element array with 3. If instead you want to create a hash table, then you're going to use pairs. So I could say A equals array, say Brad, arrow 20, Nils, arrow 18, Smiley, arrow 11. And this will create a hash table. In PHP, the most commonly used name for it is an associative array. But remember, associative array, dictionary, and hash table all mean the same thing. They're synonyms. But PHP programmers will typically refer to these as associative arrays. And you can get at them directly, the values. So you can assign values directly. I could say A of Yifan equals 16, and that will associate the value 16 with the key Yifan. Again, I could have just started it from scratch this way, and it would automatically create an associative array for me. Okay. If you are trying to get things from, I'll wait a moment for that, so keep going. Most of this you can just read yourself. Your Boolean operations can be used either and or. So for Boolean operations, you can either say $A and $B, or you could say $A and $B, whichever your heart desires. Similarly for or, you can write A or $B. The only thing I would recommend is that you be consistent. You don't mix ands with double ampersands. You don't mix ors with double pipes. The reason is that there's a slight difference in their their precedence level. So one has a higher precedence and binds more tightly than the other one. So you should be consistent when you use and an or double ampersand and double pipe. Then, just because they could, their Elsif doesn't have a space between it. It's spelled out completely, but there's no space. But you can have a space if you want, unlike Perl. So the Elsif can be either concatenated together, but it can be separated as well. And then there is something that is quite nifty to PHP and to most other scripting languages, and that is their switch statement. So in C and C++ and in Java and in compiled languages in general, your switch statements are restrict it to variables that are either integers or chars. Does anyone know why compiled languages restrict switch statements to integers or chars? So no one may have had the compilers class yet. So the reason is that compilers typically create what are called jump tables for switch statements. So if you have, say, switch in a language like, if you have int x, and you say switch x, case 1, something, case 2, something, case 3, something. What C++ typically does is it actually creates what's called a jump table with pointers to the code for each of these. So what happens is that when you actually get to a switch statement, the C compiler creates something that's effectively go to jump table X, which is really efficient. There's no comparison to see if X is equal to 1, else if X is equal to 2, else if X is equal to 3, and effectively it's just a jump to a location using X as an index variable. And that's why it's restricted to integers and chars. Chars because chars are ASCII encoded integers. Okay. So compiled languages, this was a nice efficiency. Interpreted languages don't care about efficiency, at least, well, they do, but they're more concerned with programmer efficiency. Remember, that was one of the defining characteristics of scripting languages, is that they want to make programmers as efficient as possible. They're less concerned with the efficiency of the computer. So in scripting languages, the type of your variable can be pretty much anything you want. For example, strings. So this might be a code, and the case statements could actually be strings, like case x0318, case p183, and so on. So now you don't need a big if-then-else statement for something like this. You can just have a nice set of case statements, which is really nice. Now, they no longer can have jump tables, so they're not as efficient. Internally, these are converted into if-then-else statements, but nonetheless, makes your code look nicer. You still have to have your break statement after every clause, or else it will simply fall through to the next one. And it is okay to have a default, which will get executed if nothing else is true or matches. So you're allowed to have a default keyword at the end of your switch statement. Questions about that? Okay. Then your functions, we're back to normal functions. Functions can have, they start with the keyword function, then the name of the function, and finally a comma-separated list of parameters. In this case, there are no parameters. If you want to change the contents of an array, you need to pass it by reference, and that looks just like C++. You put an ampersand in front of the parameter. When you pass it as an argument, you don't use the ampersand, but in the parameter list, you put an ampersand that indicates that we are passing this parameter, this is passed by reference, and this gives us the ability to modify individual elements, and when it returns, those elements will be modified. If I don't do that, it passes a copy of the array. Do you think in general it's good to pass a copy of an array to a function? How about no? Does that sound right? Why? Well, because it could be huge. So in general, you should try to get in the habit in your scripting languages of passing, at least in PHP, passing your arrays by reference. Because even though we don't care that much about computer runtime, I mean, why just throw it down the tubes when all you have to do is put an ampersand in front of the name and it will make your program run a lot faster. So you don't have to code like a careless idiot. You can do certain small things to make your program run more quickly. And one of them is to pass your arrays by reference always. Okay? But if you happen to just say, if you have, $A equals array 3, 6, 8, and you call foo with $A, it will actually get passed. And over here you have function foo and $x. X, in fact, will be an array this time. It will have the contents 3, 6, and 8. It just will be a copy of $A. Okay, so please pass arrays and objects. If you're using objects, also please pass them by reference. The other difference between Perl and PHP is that by default, local variables defined in a function are local, and their scope is limited to the function. When the function goes out of scope, the local variable's value disappears. If you want, you can declare a variable as global using the global keyword, in which case the global instance of that variable will be used. Or if it doesn't already exist, it will be put into the global namespace. If you want to have a local variable whose scope is limited to the function, but whose value is retained between function calls, you could declare the value as static, which is just like C and C++, which means that the variable is undefined outside the function, but inside the function, between function calls, it retains its value. This is unusual that you would use the static keyword, but I am mentioning it in case you find a need for it. So PHP essentially ripped off include from C and C++. So if you want to include another PHP file, you use include. If you want to include it only once, then you say include once. And C and C++, remember that you sometimes have to use if def and if not def to prevent things from being multiply defined. In PHP, you can ensure that a file is included only once with the include once command. And that should be placed in front of the file every time it's loaded. So for example, I might have here, let's say I have include tax.php, and I have include b.php. And let's say that b.php has an include for tax.php. This is where include once comes in handy, because now tax.php gets loaded twice, once there and then once a second time when b.php is loaded. Okay, so typically you would say include once. Generally you say include once rather than include. And you have to put it everywhere, because otherwise the purpose gets defeated. If I just put it here and here but not here, then actually tax.php will be included twice. Because include once, what it tells PHP is it says first check if the file has already been loaded. And only load if not already loaded. Not already. So the problem is, by not putting include once here, this statement here loads tax.php because it's not yet been loaded. So this loads because it's not yet been loaded. Then when even if we had include once b.php, it will check b.php wasn't loaded. Now it will come down, and because you didn't put include once here, it will unconditionally load tax.php a second time. So you really do have to be careful if you're going to use include once to use it everywhere. Otherwise, the point of using it kind of gets defeated. Okay, so useful numeric functions. There are some really nice numeric functions in PHP. It's easy to get the floor or ceiling of a floating point number. It's easy to get the max or min of a group of numbers. And it's really easy to get a random number between min and max, which is sweet, because actually you often need to generate random numbers with web applications. So that's really handy. Now, printf, while it exists in PHP, is actually rather useless. Why is that? Because printf is normally used to print nicely formatted strings for the console. But as you've seen, browsers ignore new line characters. They also have an annoying tendency to ignore lots of spaces between things. So for example, going back here to my foo.php, if I say this is and put a lot of spaces between headline, you will see that it's going to ignore them. It only uses one. So generally browsers completely collapse spaces to a single space. So in general, formatted output is pretty useless. Hence, printf doesn't tend to be a particularly helpful command. Okay, the one time it is a helpful command is if you want to do something like pad numbers with leading zeros or leading asterisks. Then you can put a apostrophe and the leading character. That's useful for things like checks. But it's more likely, if you need a formatted string, that you would use sprintf, because printf writes to standard out, and as I just got through saying, formatted output is pretty useless to standard out, but sometimes it's helpful to create formatted strings. For that purpose, you use sprintf, and it looks just like it does in C and C++. Okay. File I/O. This is rigidly controlled often in PHP, so you may have some issues with not all of these file commands working. They'll work for you at the command line, but they may not always work for you when it's run as a web page. In general, the file commands look a lot like C and C++, but there are some additional file commands to make it easy to suck in complete files. So the command file get contents sucks in a complete file. Not only does it open the file, so file get contents, what it does is it opens the file, reads the file as a string, reads entire file as a string, and closes the file. That's pretty handy, as long as the file is not too big. Don't attempt this with enormous files, or you could run out of memory or get forced into virtual memory. But it works really well for small files. And file put contents does the same thing. It opens a file, reads or writes the entire string to the file, and then closes the file. So it's a nice way to dump all the contents of a file that are contained in a string back to a file. If instead you want to read an entire file and get it line by line in an array, then that looks wrong. It's just the file. You don't need a $ file. Just say file. So I'll get that out of there. So the file command will read the entire file into an array, and you'll get an array of lines with the new line characters still affixed. So you'll have to use trim to get rid of the lines. Otherwise, files are opened, closed, handled just like they are in C and C++. You generally will get a line at a time from a file by using fgetS. You will put a line at a time by using fputS. If you want to read from standard in, which is incredibly rare because typically you're reading from a web browser, not from standard in, you use the built-in file handle standard in. So you can read from standard in, but that's incredibly rare. Similarly, you can write to standard out with either printf or, actually that's not true. Printf, you have to say standard out if you want to write to the console. So in a web application, when you're running in a web application and you want to get standard in, that's how you do it. It's just, actually I don't think you have access to standard in a web app. So this is just, PHP was not configured to read from standard in or write to standard out. It was configured to read from a web browser and write back to a web browser, okay? Or to read from a file and write from a file. It wasn't meant to write to the console or read from the console. Okay, now if you run PHP from the command line, then your print commands will in fact write to standard out by default. Okay, these commands are pretty much guaranteed not to work. They'll work at the command line. They're pretty much guaranteed not to work when you run them from the web browser. They're just too dangerous. So these are all commands to manage your file system. Okay, actually changedir might work. It's the one command that might work. Might not though. Okay. Something useful if you want to print an entire array, print _r. I have no idea what the _r stands for, but it prints the array in a readable format. So it looks something like this when it's output. So that's a nice way to look at the contents of an array. You can use array push to push elements onto the back of an array, but you could also use that syntax I showed you earlier, like that, to push a single element onto the back of an array. You can also remove elements from the front of an array and add elements to the front of an array using the shift and unshift commands, but they're super inefficient. They're order n because arrays are implemented as arrays in PHP. You can sort. There's a whole array of sort functions that will sort your arrays depending on whether they are values or, you can, a sort will sort on the value, k sort will sort on the key, assuming that the array is an associative array. Adding an r will do a reverse sort. And there's ways to specify, by default, it does an alphanumeric sort, but if you want numeric, there's a constant called sort numeric that you can give. And sorting is done in place. Okay? Last thing, and then I'll let you go. We'll get to regular expressions next time. For each is also available to you in PHP, but it's a little different than it was in Perl. So for each is the array or list goes first, then the keyword as, and then the loop variable. So it's the array first, then the keyword as, then the loop variable. And if you want, you can break an associative array into its key value pairs using that notation, an arrow between the loop variable indicating the key and the loop variable indicating a value. And all the other for and while loops work as you would expect. As you already saw, the increment and decrement operators work for you just like they do in C and C++. Next time, we'll quickly talk about regular expressions next time and how they're implemented in PHP. Then I believe we get into form data and how that's set up in HTML. So I will see you on Thursday.